Moving on, now we've gotten the formula for maximum height. The next formula we're going to look at is moving on to the number 3 equation for motion. Okay, since we are for vertical motion, we have the h to be equals, h equals uyt plus or minus half gt squared. Now, since we are moving upward, we're going to be using a minus sign because moving against what now? Gravity. Okay, so h equals uyt minus half gt squared. So we can completely now say that here becomes u sine theta times capital T minus half g capital T squared, just to use the entire motion. Okay, we turn small t to capital T because we're dealing with the entire motion of the projectile. So this is the formula for height relating to time in the given what now question. Now the next part we will look at now. Remember we said r was equal to u cos theta times t, and already we have a formula for capital T that says 2u sine theta over g. So we can write an expression for range that doesn't depend on time. Okay, because here range depends on time. We can have an expression for range that doesn't depend on time, meaning we're going to substitute the value of t into this equation. So we can say, recall again, r, like we said before, which is u cos theta t, can now become r equals u cos theta. Now what is t? T is 2u sine theta all over what? All over g. Okay, so simplifying further, you're going to have u times u gives you u squared. Then we have 2 sine theta cos theta all over g. Now there's a mathematical relationship between this expression here, okay, in trigonometry, which we know. You can recall that 2 sine theta cos theta equals sine 2 theta, meaning wherever I see 2 sine theta cos theta, I'm going to put sine 2 theta. So let's get that done. So we can see r becomes equal to u squared sine 2 theta over g. Now this is formula for range that doesn't depend on time. It just depends on the angle and the initial velocity. Now something occurs, okay, when the angle is equal to 45 degrees. We have what we call maximum range. Okay, so maximum range occurs when the angle of projection is equal to 45 degrees. Now if you put that value here, 2 times 45 gives you 90, and what is sine 90 gives you 1. So we can say maximum range becomes just u squared over g, the formula for maximum range. Altogether, okay? So these are the formulas we use in solving questions under projectile motion. Now there's one more equation we have, which we call the trajectory equation. Okay, the trajectory equation. The trajectory equation relates, okay, the height and the range together. Meaning we're gonna have an equation that expresses both height and range in just one expression. Okay, how do we do that? Now, from this given expression, we all know that h is now u sine theta capital T minus half g capital T squared, and then we know that r equals u cos theta times t. Now let's make t the subject of formula in this expression. So that we're going to say t to be equals r divided by u cos theta. Okay, and therefore we can substitute this value into our h equation. So we're going to say h becomes u sine theta. What is t? R divided by u cos theta minus half g, open a bracket, r divided by what? U cos theta all squared. Simplifying further, you can take out u, okay, and then I always tell my students, what is sine gyrin divided by cos gyrin? That gives you tangerine. So we can say sine theta over cos theta equals tan theta. So we can say r tan theta, okay, minus half g r squared over u squared cos squared theta. This is what we call the trajectory equation. The trajectory equation. Okay, because it relates both the vertical and the horizontal motion of a projectile. Now this is the end of projectile motion. We're going to see a few questions, maybe 3 or 4, just to master the equations given before now. Okay, question number 1 as shown on the screen. It says a tennis player serves a ball horizontally with a velocity of 23 meters per second. If the ball hit the ground 18 meters horizontally from the point vertically below the point of projection, find the height at which the ball was served. Now we're going to give you a diagram to understand this concept, okay? So we have a particular height and the ground, and a ball was launched horizontally, okay? We're going to move this way and then fall to the ground. So we're given the horizontal distance from the landing to the foot of where it was projected as 18 meters. So we have here as 18 meters, and we are actually asked to find the height from which it was projected. But we're given the velocity at true u. U was given as 23 meters per second. So now, quickly, first thing first, because it is said that it was projected horizontally, okay, now this means that the u you'll be given in the question is actually equal to ux. Why? Horizontal is the x-axis, okay, and uy must be equal to 0 because there is no projection in the vertical. So this is the first step we need to bring out to get this correctly. Are we together? Now, since we have this already, we can then go further to solve by bringing out the equations we have. Now, I'm sure you know, since we have r range, we can find t. Recall, r equals u cos theta times t, or r equals uxt, okay, because ux is u cos theta. Now, we were given u, which is ux in the question, as 23, and we have r the range as 18, so we can find the time of light. So we can say r is 18, so 18 equals ux is 23, then times what? Times t. So we can say therefore t becomes equal to 18 over 23. So dividing these two values will give us 0.783 seconds. So this is the time of light for this motion. Now we can find height. Recall h was equal to u sine theta t, okay, minus of, since we are coming down, it becomes plus in this case, plus half gt squared. Now remember, this u sine theta is actually uy, but we said uy was 0, so everybody here becomes what? Becomes 0. Okay, it's a horizontal projection, so the uy, the vertical velocity, is 0. So we now have just h to be equals half gt squared. Now g is 10, and then the time we just solved for was 0.783, so squared. So what would that give us? Okay, so square the time times 10 times 0.5. So the height of this cliff or projection becomes approximately 3.1 meters. This becomes the answer to this question, 3.1 meters. Okay, now guess what? We can solve this question in an easier manner. How? By applying, remember, the trajectory equation. Okay, now this question is relating range and height, okay, without time. So if you recall from our previous derivations, we discovered that h was equals to r tan theta, okay, plus or minus half g r squared over u cos theta, or u squared cos squared theta. Okay, so we had this in our previous derivation, u squared cos squared theta. Now we can use this formula to solve this question. How? Don't be confused or scared. Now, you were not given an angle in the question, but I'm sure you agree with me that the angle in this question is basically, okay, just 0 degrees, 0 degrees, because the angle we're using is the angle from the projection to the horizontal. So since it was just along the x, there's no angle increase, so the angle is 0. So what's tan 0? Tan 0 is 0, so everywhere here becomes what? 0. So we're going to say h becomes equal to half, okay, g is 10, okay, times what's r in the question? 18. So having squared, so 18 squared, okay, divided by, everybody here is ux, so we're squaring the value, and u was 23, so we have 23 what? Squared. So if you punch this in your calculator, you're going to get the height as 3.1 meters easily, easily. This is why the trajectory equation is very important. You understand that. Okay guys, question number 2 as displayed on the screen. It says, a tennis ball is thrown vertically upward from a point P with a velocity of 50 meters per second. Calculate the time it takes the ball to return to point P. So we have something of this nature, okay? The ball is at point P, shown vertically upward. So it should return back to what now? To this same plane P, okay? This same plane P. So it's shown vertically upward. Now, in this kind of question, because the point of projection and the point of landing are on the same plane, then we can apply the derived equations of projectile. Since we're asked to find the time it takes to leave the ground and come back to the ground, that simply becomes the time of flight, which we know as 2u sine theta over g. But recall, it was shown vertically upward, so the angle is actually what? 90 degrees. Okay, so you can just say 2 times the velocity at projection was how many? 50. So we have 50 then times sine 90 all over 10. Okay, so this gives us 100 times 1 over 10, and the answer should be 10 seconds. Should be the answer. 10 seconds. Okay. Okay, the next question as shown on the screen. It says, a body is projected with an initial velocity of 60 meters per second through an inclination of 30 degrees to the horizontal. Calculate the magnitude of the resultant velocity after 2 seconds. Now recall, for this question, we're going to be applying v as equals square root, okay, of vx squared plus vy squared. Why? We're asked to find the magnitude of the resultant velocity, meaning it's going to have both vertical and horizontal. So how do we solve this? Quickly recall, Vx is just equal to u cos theta, don't forget, while Vy is just u sine theta minus gt. Okay, so let's solve for Vx first. Now in the question, we're given the u as 60, so we have 60 cos, the angle was what? Was 30 degrees. 60 cos 30, those give you 60 times root 3 over 2, and that becomes 30 root 3 for the Vx. Okay, and then for the Vy, we're going to be saying u sine theta, so 60 sine 30 minus 10 times, the time was given as what? 2 seconds times 2. So we have, this is 60 times half, that will give you 30. So we have 30 minus 20, and that gives you 10 meters per second. So therefore, the resultant v becomes square root of, okay, 30 root 3 all squared plus 10 squared. Okay, so if you punch your calculator for that answer, okay, 30 root 3 all squared plus 10 squared equals, and square, we're going to give you 20 root 7. Okay, so we have 20 root 7 meters per second as the answer to this question. Okay, the last question for this series. Okay, it says a stone of mass, as shown on the screen, 0.7 kg, was projected vertically upward with a speed of 5 meters per second. Calculate the maximum height reached. Okay, so we are projecting the object vertically upward, okay, meaning it's a vertical projection, and we are asked to find the maximum height. Recall that the formula for maximum height when given to you was u squared sine squared theta over 2g. Now because it is projected vertically, the angle is also what now? 90 degrees. Okay, so we're going to be having h max to be, what was the u given? The u given was 5. So we have 5 squared, okay, sine 90 all squared divided by 2 times 10. So we have 25 times 1 over 20. Okay, so we have 25 over 20. What does this give us? Let's see. 25 divided by 20, and that gives you 1.25 meters. So the maximum height is 1.25 meters. Okay, now this is the end of the series. Okay, if you have more questions on projectile motion, please you can drop them in the comment section so I do a video for you on how to solve them. Please, if you're new to this page, kindly subscribe, comment, and share to your friends as well. God bless you.